Good morning everyone. I am Satyakash. Today I am going to discuss about early stage stomach cancer identification using image processing. Problem statement. Endoscopic images have been playing an important role in identifying gastrointestinal cancer because it enables the physicians to directly diagnose the gastrointestinal tract. It is the most common method for identifying and diagnosing the gastrointestinal cancer. However, the accuracy of these diagnostic results is limited by experience of practitioner. This accuracy is about 75 to 80%. Thus, the need to implement a method for improving the accuracy of diagnosis through endoscopic images is increasing exponentially. Existing system. The existing approach for gastrointestinal cancer identification is a computerized decision support system that has been implemented with help of specialized doctors and image processing techniques. The mentioned computerized decision support system works as an assistant to the doctors of gastroenterology, helping them to identify the cancerous area in the endoscopic images of intestine. The image processing technique used is statistical region merging (SRM) technique, which is used to identify gastrointestinal cancer. But the results generated by this technique are imprecise in identifying the gastrointestinal cancer, and its accuracy is also less. Proposed system. This enhanced approach involves implementing a new deep learning based convolutional neural network support module for identifying gastrointestinal cancer. CNN performs image processing as well as image classification to identify gastrointestinal cancer through endoscopic images. The results yielded by this model have high precision rate and state-of-the-art accuracy. The high processing speed of this also helps the endoscopist to diagnose better. Methodology. This is the flow of our project. First we have collected the images, then these images have been pre-processed and features have been extracted from the images, and finally through training and testing we have developed a stomach cancer identification system. The features extracted are mean, standard deviation, entropy, RMS, variance, smoothness, kurtosis, skewness, IDM, contrast, correlation, energy and homogeneity. Dataset collection. The images required to test are collected using endoscopic equipment at Vestreviken Health Trust in Norway. The VV Trust consists of 4 hospitals and it provides healthcare to almost 50,000 people. We have collected these images from Simula, an open datasets website. The dataset is annotated and verified by medical professionals and specialized physicians. The resolution of the images in dataset range from 720 into 576 pixels to 1920 into 1076 pixels. The dataset comprises of endoscopic reports of both healthy and cancer-affected people. Dataset preprocessing. We have preprocessed our dataset in 3 steps. The first step is image resizing. From the obtained dataset, we now know that the images are of different resolutions. So initially they are resized into a fixed resolution. Making images get adjusted to a fixed resolution helps in extracting features such as lesion size, number of lesions, which are important to be found from endoscopic reports. The second part is grayscale conversion. The resized images are then converted into grayscale since it's easier to process the grayscale images, which in turn reduces the complexity of images. The conversion into grayscale is done by taking the average of RGB, red, green, blue values of the image. The third part in our dataset preprocessing is filter application. Now to the grayscale image, median filter is applied to reduce the noise. Application of appropriate filter to image is effective as it reduces the noise without softening the image. Median filter is highly effective in terms of reducing the salt and pepper noise of image, simultaneously preserving the edges which are crucial for resident recognition. Feature extraction algorithm training. The extraction process results in unsheathing a total of 13 features from the images present in data, on the basis of which cancer is identified. After the required features are extracted from the inputs, the neural network model is then trained to identify the image, based on which it's classified as either cancerous or non-cancerous. These are the features that have been extracted. We have extracted a total of 13 features. They are mean, standard deviation, entropy, RMS, variance, smoothness, kurtosis, skewness, IDM, contrast, correlation, energy and homogeneity. User interface. After the required features are extracted, the neural network model is trained and the displaying of output page comes into the picture. Once the output page is displayed, the user is required to browse or select the image he wants to identify, after which the required output is displayed. Along with the segmented image, the features that have been extracted during the feature extraction module are also displayed. Results. This is our final output page. Here we need to input our endoscopic image, and this is the segmented image. And here we can see all the features that have been extracted, and here we can see the type of cancer, whether it is malignant or benign. Conclusion. Therefore, this approach involved in development of a computerized decision support system that can aid the physicians and doctors to easily detect the gastric cancer at an early stage with accurate results, which is proven to be very useful. Due to the usage of an algorithm that has high detection rate as well as high processing speed, the obtained model is precise and reliable. In conclusion, from the obtained results, one can assure that this method is very useful for endoscopic examination of cancers. Further improvement scope. Currently, this model is only limited to gastric cancer, but in future this could be developed into an advanced model such that all types of cancers can be detected using this computerized decision system, where the endoscopic reports are used to detect the cancers. Existing literature. This is the existing literature on our project, which is early stage stomach cancer identification using image processing techniques. References. These are the various references from which we have used to develop our project. Thank you. Now we are ready for question answer session.